Here we are designing the boost converter with the different modeling approaches. That is, initially the boost converter is designed with detailed model, and then it is designed with mathematical model, and it is designed with average model, and we are comparing the results of these three models. Here this is the mathematical model, time interval, and input is given as the inductor current, and this is the duty ratio generated from the PID controller. That is the closed loop. From this, using the function, we are creating a mathematical model. Just two outputs we are generating: DIL, DV naught. That is change in inductor current, change in voltage. Depending upon these equations, we will get the outputs: voltage and inductor current. And that output is given to the controller. Here 48 volt is the reference that is compared with the measured voltage, and error is given to PID controller. From that, current signal is generated. That current signal is multiplied with the sinusoidal waveform to get the reference current, and that will be compared with the inductor current, and error is given to PID controller. The PID controller will generate the duty ratio, which will be fed back to the converter. In this, the outputs voltage and current, reference voltage and the measured voltage. So we have to run it. Similarly, average model and detailed model we are designed with same parameters. Here in detailed model, the sine wave input is given, that is rectified. The rectified output DC output will be given to the boost converter. The boost converter, depending upon the duty ratio, it will boost up the voltage and provide it to the as the output. And that duty ratio will be decided by the controller. Here in this, if you see, this is the output voltage and output current of the detailed model of boost converter. Reference voltage is given as 48 volt, so it should settle at the voltage of 48. Okay, here it is settling at nearly 48 volt, and then in the mathematical model, the output voltage and the reference voltage is provided here. Reference voltage is 48 and the output voltage is also settled at 48 with the peak overshoot. And then average model, in this is the output voltage. Here also, here output voltage is settling at 40. So the average model with the PID controller, it is not settling at the reference voltage. It is settling at 40 and it is slightly increasing. It will take some time to get the reference voltage. with a detailed model, sorry, average model. This is the inductor currents for all the three: average model, detailed model, and the mathematical model. Here we have checked the design the boost converter in three different approaches, modeling approaches. One is detailed model approach, which the actual circuit we will design it, and one is mathematical model, where the equation based on the equations we will model and get the results. Another one is average model, where we will construct a transfer function, and based on that we will create the model. So based on the three modeling approaches, we have seen the results. And this is the power factor. As we are using the AC source, we are checking the power factor. The power factor is around 0.99. So it is nearly unity power factor, 0.992. That is the power factor we have obtained.